Lesson 5, 6 out of the book is a little different. If I had my choice, I'd maybe leave it off, but we've got to plow through it, get through it. You've got a sheet, you just did your warm-up. Mrs. Johnson, hopefully this is her last day and I'll be back. We need to get through this. It's called the Hinge Theorem. Kind of goes like this. Here's your sheet, looking at the sheet, follow along with me. It says, you're supposed to figure out, number one, AB compared to DE. You're supposed to say if it's less than, greater than, or equal. Less than points to the left, greater than, bigger, equal, you know what that is. AB compared to DE. Well, AC and DF are the same. BC and DFE are the same. All it is this. If this angle is in between, and it's bigger than this one, and these outsides are the same, if this is the larger angle, then this is the larger side. DE has to be bigger than AB. Now, to say that on the way the paper has it, you'd have to put less than. AB is less than DE. Two sides the same. This is the same as that one. This is the same as that one. The angle in between them. It's got to be in between them. Go ahead and do part 2, number 2 on your own. Stop the video. Number 2 has to be equal. Because same sides, same angle. What? Side, angle, side. The theorems about that. Triangles are the same. Problem number 3. Slight twist on number 3. You're supposed to find measure of angle 1 compared to measure of angle 2. Why did I turn the triangles upside down? To confuse you. If you have angle 1 here, and this side is the same as this side, and this side's 7 and this is 8, and you're comparing angle 2. Again, if we turn the triangles around, you might have a little better deal. Sometimes that throws people off. Sides the same. Angle's the same. That angle has to be 90 degrees, all right? If that's the case, then angle 1 has to be smaller than angle 2. This side is 8, bigger. 2 would have to be bigger because 8 is bigger than 7. Now, what exactly is angle 1? What is exactly angle 2? That's trig. We have to get into that later. But for now, that's all we can say. Angle 1 is less than angle 2. Number 4 is all yours. Ready, set, go. Angle 4, or excuse me, problem number 4, angle 1 and 2 have to be, right, congruent. They have to be the same. 6, angles the same. Unless, of course, it's not perpendicular. Is it perpendicular? Well, it doesn't matter. You've got angle, you've got side, side, side. Those two triangles have to be the same. Angle 2 is the same. Number 5, measure of angle MS, side MS, and LS. Look on the left side. MT, same as TL. The side in between, TS, reflexive property. That means those triangles are, got the two sides the same. Since the 98 is bigger than the 95, LS has to be bigger. That means MS is less than LS. Sorry about that. MS has to be how much smaller? I don't know. But it's smaller. That's all you can conclude. It's thinking. It's that reasoning. Number 6 is all yours. Answer. Angle 1 has to be bigger than angle 2. Just because it looks like it? No, we can't go by looks. We cannot go by looks. Angle 1 has to be bigger. The two marks at the top and the bottom show that they're the same. The included or side in between, reflexive property. Angle 1 has to be bigger. Number 7. ET, GT. And again, I don't know how many times you did this in your proofs, but that side that's shared, the side that they both have, reflexive property. My might have sounded kind of funny to you way back in the day, but it turns out to be pretty useful. Side there, same as that. Included sides the same. This is 28, this is 31. That means this side has to be bigger. TG, GT, doesn't matter. They've got GT. GT has to be bigger, so ET smaller than GT. Number 8's all yours. Number 8, since angle 1 and angle 2 are compared, 2 has to be bigger, angle 1 has to be smaller because the 12 is smaller than the 13. Is that it? That's it. Number 9, error analysis. Explain why the student's reasoning is not correct. It says by the hinge theorem. The hinge, you know, this angle here, the hinge, as we call a hinge. Explain why the student's reasoning is not correct. You know it's not correct. The question is why. By the hinge theorem, how come AB is greater than BC? Does the hinge theorem on this problem say that because of the hinge theorem, AB is bigger than DC? And you look at it and study it for a while, stop the tape, stop the video, see if you can figure out why. What's wrong? Do we have two angles? Yeah. Well, isn't 47 bigger than 35? Of course 47 is bigger than 35. Do we have two sides the same? Yes, we do. And isn't this the included side? So side angle side, isn't that kind of? We have a slight problem. This angle is not in between the two sides. This angle is not in between. That side over there is sitting across, that angle is sitting across from that side. You cannot say that this is bigger or smaller because we don't have enough information. It's not the included. It would have to be two sides in between. It would have to be like this angle and this angle. Side, angle, side. Side, angle, side. They turned it around on you. Can't do it that way. Next page, back side. Number 10. Ooh, matching. We like matching. Match the conclusion. Number 10. AB, let me erase this. AB is equal to BC. AB, BC. Measure angle 1 bigger than measure of angle 2. Angle 1, angle 2. Angle 1's bigger. What can you conclude? Well, if angle 1 is bigger, then A to E has to be bigger than E to C. Number 10 has to be D. How about that? Angle 1 bigger than angle 2, A to E has to be bigger than angle or than side EC. 10 is D. We're down to 3 others. I wish everything was matching in geometry. Number 11, all yours. Answer, number 11. If AE is bigger than EC, this one bigger than this one, you've got AD congruent to DC, here, here, that means angle 7 over here. Angle 7 has to be bigger than angle 8, so it's A. You're down to the last two on your own. Well, the last two on your own. Go. Got it? 12 has to be B. 13 has to be C. 13. If AB is equal to BC and AD is congruent to CD, then 3 and 4 put together have to be bigger than 5 and 6. They combine two angles instead of having one. All right? Problem number 14. Use the Hinge theorem or its converse. We haven't talked about its converse. Hopefully you know converse, contrapositive, inverse. I haven't asked you about that, but I'm taking that you have had that already. I'll check into that in the book later on. Use the Hinge theorem or its converse and properties of triangles to write and solve an inequality to describe a restriction on the value of x. You're supposed to write something for x. They threw you a variable, a little algebra. Six, same as 6. X, 7. 65, 70. All they're saying, and to me this is not like a high level thing, all they're saying is this is 6, same side. If this angle's bigger, x has to be bigger than, x has to be bigger than 7. If this is 7, this one has to be a little bigger. How much bigger? We don't know. Without trig. We could do with trig. Try number 15 on your own. Stop the video. Picking it back up, number 15. Since 38 is bigger than 30, and we've got 12 on both sides, I'm not going to draw a figure, 12's on both sides. Interior, that same angle, that same diagonal is there. 38's up here, 30's down here. That means 12x minus 7 has to be bigger than 3x plus 2. The 12x minus 7 has to be bigger because the 38's bigger than the 30 degrees. Work that out. Stop the video if you want. Answer to the problem, x has to be bigger than 1. Hopefully that's what you got. Subtract and add accordingly. Number 16. You and a friend are going shopping. Yay! You leave school and drive 10 miles due west on 26th. You drive 7 miles northwest on Raspberry. Your friend leaves school, drives 10 miles due east, opposite. On 26th, drives 7 miles southeast on Cascade. Each of you has driven 17 miles. Which of you is farthest from school? Which of you is farthest? Now I know, math is about problem solving. Are there problems about miles and speed and angles and distance? Yeah, this one, I don't know. Since the two marks show 10 miles, they're the same. On the left and at the bottom right, they're both 7 miles, same distance. If the angle that you have is 100 over here on the left, and your friend over here has an angle of 120, your conclusion? Your friend's farther. Your friend's farther because it must have gone at a bigger angle. Bigger angle, farther away. Number 17. We won't do. Skip it. We haven't talked about altitude. I must have not caught on that. We haven't talked about indirect proof. This is about it. Finish the rest of the time with some problems at the board, and we'll see you tomorrow.